Go ahead.
So, well, I did ask which of the following could be a table for values of f at the end, and it gives you different like clues of f prime and f double prime.
So let's pause for 1 second. So we know these are all values of f.
Mm-hmm.
Awesome, good there. And you're right, it gives me these clues here.
Yeah.
Keep going.
So the first one, f double prime is less than 0, so that means that it's always going to be negative. So that means the graph of f is going to be concave down.
And let's write that out. So that's Danica's chart.
Mm-hmm.
If we know that f double prime is always negative, then we know that the curve of f will always have a concave down shape.
Yeah.
Good.
And so I would look at how the values kind of turn out as the values increase. And so for A, it goes up by 1 or 2.5 and then by 1.5, so it's possible.
We pause for 1 second. It's important to always keep track of what's happening over here, just to be safe. These are only changing by 1, so that's pretty easy. So over here, the y values change by 2.5. The x values change by 1. You're calculating a secant slope. And you are finding correctly that the secant slope is changing from 2.5 to 1.5. You need to memorize the definition of concave down. I believe it is on the golden notes. Right here. So at the very bottom of the back side of the first sheet, it says right here. Now this definition is for concave up, but you just switch it for concave down.
Okay.
So it says right here, if f prime is increasing, in our case, f prime is decreasing. We just showed that. It's right here.
Yeah.
We've got f prime is decreasing. So back to the notes. If f prime is decreasing, then as you observe tangent and secant slopes of f, so as you look at the graph of f, you draw a graph. Like if f is concave down, then as you follow f, you go from point to point to point, you're going to always find that if you follow secant slopes like this, from one secant slope to the next, you'll see a decreasing values of slope.
Yeah.
If you were to follow tangent slopes, you get exactly the same result. This slope to this slope to this slope, the slope values decrease. If you alternate, like you go from this secant here, and then you compare that to this tangent, the next one you hit, you notice that from that secant to that tangent, there was a decrease. So that's what the golden notes are reminding you of, is that whenever we have in our case, this was concave up, but the tangent and secant slopes have to follow that increasing or decreasing pattern. That's the big idea.
Yeah.
Back to the problem. So you're right. This looks really good. I've got a secant slope followed by a secant slope. Definitely a decreasing pattern. This is definitely a possibility so far.
Yeah.
Keep going.
And so then on B, it does the same thing, 2.5 and then 2 for the next value. And so that could possibly work as well.
Keep going.
And then the same thing on C.
Keep going.
And then D doesn't work because the values of the secant slope are the same.
Keep going.
And then E does not work as well because the values of the secant slope are increasing.
Very good. So far we've got this pattern that on the first three tables, we definitely see secant slopes that are going down in value, which is what we have to have for f to have a concave down shape. And then you said nicely that here the problem is the secant slope doesn't appear to be changing.
Yeah.
Secant slope is 2. And as I move to 2 different points on the curve, the secant slope is still 2. And here the problem is the secant slope is going up. Keep going.
So another clue that it gives you is f prime of 3 equals 2. And so that, you know that the slope of the curve at f of 3 is going to equal 2.
Let me say it slightly differently. This means that the slope, the tangent slope of f, not f of 3, the tangent slope of f at an x value,
Oh, because f of 3 would be the y value.
Yeah,
Okay.
the tangent slope of f at an x value of 3 is 2.
Okay.
Yep, keep going.
And so then I went and kind of did the same things with the slopes. And so I initially chose C because from 3 to 5 there's a slope value of 2. And so I thought that fulfilled that requirement.
So let's draw a picture of what you just said. So if we were looking at item C, we just did a quick sketch. We know the graph of f is supposed to, it has to be concave down. Right? We know that between the first 2 points on f, the secant slope was what value?
From 2 to 3 it was 2.
So this secant slope has a value of 2. But we also know that right here when x is equal to 3, and I forgot what the y coordinate is,
5.
5, thank you. At that exact spot, there is a tangent slope whose value is 2.
Oh,
So this
that can't work
that
if it's
can't work.
decreasing.
There you go.
Okay.
That tangent slope right there is 2. You can see from the picture we've got something that's not even possible.
Yeah.
How can I possibly have this red line have a slope of 2 and the green line have the same slope?
Yeah.
No way if the curve is concave
Yeah.
down.
And so that would work with letter A because it's a 2.5 and then a 1.5.
There we go.
And so it would work, right?
Yeah, I can draw that one. So I can go here and say, yeah, for letter A, if I draw F, F still must have a concave down shape. I still have a point right here. Is it 3, 5 still?
Yeah.
So I have a point here at 3, 5. But now everything works. Because if I draw this secant slope, which according to the table, that secant slope has to be 2.5. This next secant slope has to be 1.5. Well, that's very reasonable. Like that.
Yeah.
A tangent slope in the middle of 2 is reasonable.
Yeah.
And it can be anything, it just has to be between.
Yeah.
Yep, that's it.
Okay, perfect.
Good work. So correct answer is definitely A.